But of course, I, on the other hand, get to make all the funny comments and whatever that I want to. So that's what I'm able to do. Thank you, everybody, for showing up. I am Alan Clegg. I've worked for ISC for a number of years in a number of different roles. And as Vicki said, you know, this is kind of a throwback for me because I was a Unix instructor way back in the day, back in the very early 90s. And I haven't really done any Unix system admin training in that length of time. But I do think it is something that actually is very, very interesting and very useful. Something that we do need to have some filler on. So today we're going to talk about the Unix command line, and it's something that a lot of people really aren't doing anymore. There's so much work in the graphical user interface that there just isn't the amount of skill set out there knowing Unix as there used to be. And one of the things that happens here is a lot of times people get pulled in from job positions that they weren't really a Unix person to begin with, and they get kind of dropped into the role of a DNS or DHCP administrator, and so they run into some little issues with how do you go about doing something from the Unix command line. So today we're going to talk about the basics that you really need for BIND, ISC DHCP, and Kea administration. And one of the things that I'm a Twitter person, and one of the things that I came across the other day was a quote from Leslie Carhart, who is one of the InfoSec people that I follow on Twitter. And she posted that, you know what really pickles my beets? When InfoSec people rely on a tweet about something in security being overly complex for end users with something like, oh, but it's no problem. They should just, do this complex technical install. They should do this workaround that they found on GitHub. And then there's only this easy 14-step process. And unfortunately, that's kind of the way that we've begun to look at the Unix admin portion. There's so much that we say, oh yeah, just go in and edit this file, or look at this log file, or look at the process. And unfortunately, the skill behind that is something that we learned so far back that it's just second nature. And one of the follow-ups to Leslie's post was Zeke, who said, it's kind of like when you're told how to draw a horse. Step one is to draw an oval, and then step two is to draw the rest of the horse. And most people seem to forget where they came from. We don't want to spend the time helping others to climb up, the same ladder that we had to. And it's unfortunately across all industries. So this specifically was talking about InfoSec, but it is also very relevant in the DNS and DHCP world. So we're going to work on drawing that oval and hopefully getting you, or getting everyone as much as we can, up to the point of being able to work from the command line and not be uncomfortable with that. So one of the things today is that the commands that I'm going to be giving, that I'm going to be talking about, are very, what I would consider to be generic Unix. It's things that really aren't specific to one version of Unix or another, but unfortunately that does not mean that it's going to be the same across all platforms. One thing that we've discovered the hard way often is that certain commands have different options available. The PS command, is it PS-EF or is it PSAUX? And they basically do the same thing, but depending on what platform you're on, the different options that you give you different outputs and work in different ways. So what I'd like you to do is make sure that you understand that the work that I'm going to be doing today, the things that I'm going to be showing you, are a mixture of CentOS and Raspbian. And there are going to obviously be differences between other versions of Linux. If you're working with FreeBSD on the FreeBSD distributions, there are going to be differences between that. So be sure that you read the man pages. And that is the center of that slide. And it is very important. If it doesn't work the way I'm showing you here, then you probably want to look at the man pages, because there's going to be a way to do it. It's just not the way that I showed you how to do it. The other thing that I'd like to point out here is that this isn't just a Unix admin for DNS and BIND and DHCP and Kea administrators. It's basically a Unix cheat sheet or a Unix way of doing things that can be used for any of the services that you have running on a Unix host. There's nothing that I'm going to be talking about except for the very, very end that is specific to any of the ISC applications. So what you're going to see here is something that, oh gee, you know, well, if he's able to debug, you know, BIND with that or Kea with that, then maybe I can use the same types of things to help discover information about, you know, MySQL or maybe Apache or Nginx or whatever other things that you have running on your Unix box. So in the samples that I give, obviously I use, you know, the names named and Kea and DHCPD. If you replace those words, if you're, for example, looking at a grep statement or a PS statement and you see it's PS something named, if you replace that with Kea, then you're going to be looking at the same type of information, but for a different application or a different project. So again, the same thing with Kea. If you see Kea, you can replace it with named or, you know, any of the other applications that are running on Unix. This is non-denominational Unix. So what happens when all else fails? Well, I've tried this, I've tried that, and none of it seems to work. The biggest thing that Unix, that for a long, long time, Unix had going for it was man pages. You always had the Unix manual available to you when you were typing something from the command line. If you typed ls and hit return, you would get a listing of the files in the file system in that directory. But, you know, there were a whole bunch of other things that you could do. So what you could do was read the friendly manual page or RTFM. And in this case, the command that I'm talking about is the man command, and that's short for manual. So if you type man space man, it gives you the manual page about the man command. So if you want to know the manual page about the Kea DHCP v4 server, then you would type man and then Kea DHCP v4. So man gives you an interface to the online reference manuals. In the synopsis, you'll see there's a lot of stuff. There's the command right there where it says man, and then there's some brackets and then a whole bunch of other things in brackets. Anything in brackets is optional. So if you just type man space and then a command without giving any of those other options, you're going to get the manual page for that command. If you do man-k and then a regular expression, it's going to give you a list of the manual pages that are associated with something similar to that command. And so you can look at all these man pages, and I show this because, as I mentioned earlier, there is going to be the time where you try the command that I have listed on the screen here, and it's not going to work exactly like it did for me. And what you'll need to do is go back and read the man page on the command that you're looking for, and you'll get some more information about it, how to give it the right options to have it do what you want. Now at the top of the page, you'll see that I have man and then in parentheses the number 1. And what that number 1 is the section in the manual in which that command or option or file format or file or whatever is found. So the manual is broken up into multiple sections. So in this case, the man sub 1, or in parentheses 1, says that this program or this man page can be found by doing a man space 1 space and then the command man. By default, section 1 is used. So if you just type man space ls and hit return, you're going to get the man page for the ls command. Now, if you notice number 5, it says file formats and conventions, e.g. /etc/password. Now, from a Unix perspective, to change your password, you run the command passwd. Well, that's all well and good, but if you want to know the format of the things that are found in the file /etc password instead of knowing about the command password, you're going to need to do a man space 5 space password. So that's going to pull up the man page about the file format about password instead of the executable. If you want the one about the executable, you just type man space password, hit return, and you're going to get the thing from section 1 by default. So thinking about what's going on in our file system, we're thinking about the commands that we're going to run or the programs that we're going to execute. We're going to need to be able to figure out where they are in the file system. So we're going to do a little bit of wandering around the file system in this first section. So I'm going to talk about the commands locate, and I'm also going to talk about a little bit of grep and more and less. Those are some important commands to understand and some of the things that you can do. Also, I'm going to talk about the command find and the command which. Now, locate and find you may have seen, which you may be familiar with, but let's go into them a little bit more in detail and see what they are actually able to do for us. So locate is a command that locates files quickly in the file system based on a database that is rebuilt every once in a while. So every once in a while, there's a job that goes out and it builds this locate database. So at that moment in time, that database matches exactly what's in your file system. You can type locate space and then a file name or a portion of a file name. Locate command will go out to that database and it will find the locations of all of the names that are associated with that in the database. Now the problem with this, I mean, it sounds fantastic and it's very fast. It doesn't rely on the speed of your file system walking down through the file system, but it may be out of date. It is much faster and less resource intensive than the command find, but unless you're doing it right after the database was rebuilt or what you're looking for hasn't moved in a while, it may not necessarily be able to find it. In addition, locate may not be installed by default. I'm an old school Unix guy, and I'll tell you that locate was part of the BSD distribution way back in the early days, and I was really surprised to discover that I installed CentOS and I did a locate file name and it didn't find it, or maybe it was Debian, or maybe it was Ubuntu. Anyway, wherever I was trying it, I couldn't locate, and the update database command weren't there. So what I had to do was I had to go out and look for a package that contained it, and it was actually called mlocate. And I honestly don't know what the M stands for, but it does include the locate and all of the additional pieces that make locate work. So let's look at the command grep. So grep, as very few people actually know, stands for Global Regular Expression Print. And this came from a very early version of a Unix editor on the command line, where the actual command was G/ and then a regular expression /P. And what that was, then obviously GREP. And so the command from the command line grew from the name of the editor command. What grep does is it finds patterns in files and displays those lines to your screen. You can do things if you're familiar with regular expressions. You can have repeating characters. You can look for only a numeric value. You can only look for a character between certain other characters. But in this case, I'm not going to get into all of that. You can go out and read the man page, which obviously from the top of the slide is in section 1 of the man pages for grep. And you can get a lot of additional information and a whole bunch of different options for the grep command. One of the neat things about grep is that it can also negate the search. So I can go in and I say, I want to find all of the lines that contain not a certain string. So if I know that my log file, for example, is full of the string enthusiasm, then I can go in and say grep-v enthusiasm and give it the name of a file, and it's going to show me every line in that file that does not have the word enthusiasm. So let's look at more and less. Well, again, I'm really old school, and so I was brought up using more. And a lot of people look at me and they go, my goodness, I can't believe you use that because less is so much better. Well, as far as I'm concerned, both of these are paging commands. They take the input usually from a pipe or from the name of a file. They bring in that file, and then they page the output so that it can be digested by a human. So if you just type cat space and the name of a file, it's going to be displayed to your screen, and it's going to roll by as fast as it possibly can, as fast as your output is able to go. That to me isn't all that useful. Yes, I know I can scroll back with my X term, I can scroll back, using the buffer, but I really am more interested in, perusing it at my speed. So what I can do is say more space, the name of a file, hit return, and it's going to page that file. It's going to produce the output. It's going to page one page at a time, and then I'm going to be able to hit the space bar and have it go on to the next page. Very, very handy. It can also be used it can be used at the end of a series of commands. So we might be doing some type of a command and then piping that to something else, for example, a grep, and maybe another grep, and then piping that to more. So we can see the output page by page of a number of different commands that are fed from each other's input and output. So here's a sample. I was on my CentOS box and I typed locate space Kea space pipe to more. So I did a locate on Kea, and if I had done this without the pipe to more, it would have just scrolled by and scrolled by and scrolled by very, very fast. And what I discovered was that, well, I was kind of looking for where the commands are installed and where it's actually in the file system, in the executables. I didn't necessarily want the fact that, yes, I had a source code tree for both Kea 1.5 and 1.6 beta in my home directory. So when I did this locate of Kea, it showed me a lot of things that I really didn't want. So I could have gone through paging and paging and paging, but if you've ever looked at the Kea distribution, there are a lot of files in it. So instead of letting that go on and on and on, I could hit Control-C or Q at the more prompt, and it stopped the output. So what I then want to do is I want to locate Kea, but then I want to look for any line that does not contain the string acleg. So anything that was in my home directory, as you can see at the top, /home/acleg/Kea, those all contain the word acleg, or the string acleg, obviously not a word. They are not going to be displayed, and then I take that output and I pipe it to more. So now, instead of all the source code that I have floating around in my home directory, I now get user local bin, Kea message compiler, user local etc Kea, and the contents of the user local etc Kea directory. So that's very handy. And again, I'm now using the locate command. I'm using the grep command to negate a certain string, and I'm piping its output to more. Now, as I said earlier, locate. Since I'm doing this locate, I'm assuming that whatever I'm looking for specifically hasn't been moved or hasn't been created since the locate database was updated last. So in this case, I was looking for something that I knew had been sitting around in the file system for a while. So locate was just fine. I didn't have any issues with that. Well, locate is great, but what if you just installed something and now you want to know where it actually got installed? You typed make install and 25 pages of stuff rolled by, and you know that Kea is out there somewhere, but you don't have the updated locate database, but you still want to find those files out there. So find locates the files in the file system. It starts from a given directory location and then proceeds downwards. It does not rely on that database that locate was using, but it is more resource intense because it's actually going out into the file system, looking at each directory as it goes down and producing the output for you in real time. So you'll discover that locate is extremely fast, but possibly out of date. Find is extremely accurate, but is going to be considerably slower. You really don't want to have to do a find on a file system that has multiple you know, lots and lots and lots of installed code, lots of source code, whatever, because it's going to have to go through that file system to locate the information that to give you. So here is a sample of the find command. And again, find is in section 1. So you can type man space 1 space find and hit return and get all of the options. Here I did a pwd to print my working directory. So I saw that I was in /home/acleg. I did a find of dot, which says the current directory. And then I looked for any file that contained the name that ends, or that contains conf, C-O-N-F. Now I have to put this in single quotes because the star expands the file name if there's anything in that directory where I'm running the command with conf in it. Again, something that you're going to run into as a Unix admin and as a Unix user. So the single quotes around it tell the shell not to expand the star, and in this case, find goes down through the directory looking for all of the file names that end in conf, and it shows me all of those examples or all of the files. So this was very handy, very easy, and if I had just extracted the tarball that had this Kea 1.5.0 directory in it, the locate database would be out of date, and therefore I wouldn't be able to use locate, so find does exactly what I need. Now, you've located these things, you know what they are, and you're getting ready to run a command, or you've always been using this command, but you don't know which version or where it's actually being executed from. So the which command, given the name of an executable, is going to show you which of, or it's going to give you the directory location, the file system location of the command that you're actually executing. So in this case, I locate bin password, and I see that there's user bin password and user local bin password. So if I type the command passwd, which of these two is actually going to be executed? Well, I can find out very easily by using the which command. Which it shows me that user bin password is the one that is executed if I type the password command. And then just to show you what happens if I try to give it an incorrect word or incorrect program or executable, which passwd. And what that shows me is that which tells me that there is no passwd command in anywhere in my search path. So in this case, if I knew that there really was a command called passwd, then I would have to actually go to the directory or specify the entire path to execute that command. So we've now figured out how we might be able to locate or find the command that we're doing, that we're starting or that we're executing, and we can tell which one of them we're actually doing, even if there are multiples. But how do we go about discovering where they're actually executing in the process? You know, if in the process table, we know that named is running because we're able to do DNS queries. But how do we go about finding the actual process that is running, and how can we find out more about that? Well, the commands that we're going to look at are ps, top, and then something that I found relatively recently, which is glances. And glances is kind of cool, but it's something that, again, I hadn't run into until relatively recently. So the ps command displays the process status, including the process ID, runtime, and additional information. So if I do a ps-ef, and again, this is on CentOS, and CentOS uses the EF to give me additional information, extended information. And then I grep for Kea. This is going to provide me with a listing of all of the processes that are currently running that have the word Kea in their process information output. So in this case, we see that there is an instance of Kea control agent, Kea DHCP 4, and Kea DHCP 6 servers. We are also able to see the command line. So we know that user local bin or user local sbin Kea control agent is the actual executable that's running. and it was run with the options on the command line of -c kea-control-agent.conf. So we know the name of the file that was used to configure Kea. Now we can go out and use the commands that we learned just a minute ago to actually discover what's in those files. The same thing with the Kea DHCP v4 or Kea DHCP 4 and Kea DHCP 6. Now, if you notice the word root at the very beginning of the line, that shows the user that is actually running this command. So these are running as root instances. And then the next number is the actual process ID number, the PID of that process. So if you ever wanted to stop one of these processes violently, you could do a kill 2184 and it would send the terminate signal, or it'd send the abort signal to the root run process of user local bin or user local sbin Kea control agent, and that would stop the process. So if somebody ever asks you, well, what's the process ID of that application or of that daemon, you can go out and do a ps-ef, grep for the daemon, and then look at the second column, and it's going to provide you with the process ID. Oh, one other thing here, you'll notice that the grep command itself was also found in the output of ps-ef. So when I ran ps-ef grep Kea, there actually was a grep Kea command, and you can see down there at the very bottom, it is given as grep -- color equals auto Kea. That color equals auto comes from one of the grep configuration default files. So again, read the man page on grep, and you'll figure out how to do all these wonderful colorization things. The top command. Well, you know that your machine is getting really sluggish. Your server's getting sluggish for some reason, and you don't really know why. Well, you might want to look at top, because top shows you the processes that are using the most resources on your system. It's also going to display some system status. For example, the % of the CPU that's in use, the amount of memory that's in use, swap space, and it is curses based. So it gives you a kind of sort of graphical interface, but on an ASCII terminal. It isn't going to, give you little buttons that you can click and things along those lines, but what it is going to do is it's going to give you a screen that's going to update as the information that it's providing updates. So here's the output of top. We see that top, this was run at 11:10:19. The machine in question had been up for 56 minutes. There are 2 users logged in. The load averages are listed there. The total number of running tasks. The CPU utilization, obviously it's a very lightly used system. We see the amount of memory available. We see the amount of swap space available. And then we see the amount that is actually in use. Below that, we see all of the process IDs. We see the user under which that process is running. We see process priorities. We see nice values. We see the amounts of memory that are in use by the processes. This isn't really a good example because there's a whole lot of zeros on there. And that's because this was a virtual machine. It's not really a production system with lots of users on it. It's just a virtual machine that I use for testing. So the thing that was using the most time on this server was system D. Gee, big surprise there. And the other ones are really not, they're almost all asleep. So there's not much to see here.
Hey, Alan, what's the nice value? You mentioned that. I see the NI there. What is it?
That's something that it has to do with process priorities. And if you really want to get into that, I will take you through that in the advanced Unix class. That is something that is assigned by the kernel, or it can be assigned by the application itself to allow it to be preempted to run in front of other applications. So it allows things that need to run, it gives them the ability to run even if something else is hogging the CPU.
Thanks.
Yep, no problem at all. So I told you about glances, or I mentioned glances. Glances is top on steroids. In addition to all of the information that top gives you, it also provides you with information about your network utilization. It gives information about disk I/O and disk capacities. The bad thing about it is it's written in Python and it is much heavier than top. When you run glances, or at least when I run glances, I notice that it is really the process that is using the most CPU of anything that's running on the system, because it's sitting out there grabbing lots of information and displaying it. But as you can see here, it does give a significantly nicer output. It gives us a better display. So we see the CPU percentages, the memory percentages, the swap percentage, and then all of those broken out. We also see there the network interfaces, and we see the receive and transmit bytes per second, or in this case, bits per second, of each of the interfaces. We see disk I/O on each of the disks in the system, and then we see the file system that shows the amount of space available, the totals in the total column, and the amount used in the used column. So you can sit here and watch it and see, you know, that nothing bad has gone on with your system. In the right-hand corner, lower right-hand corner, lower right-hand quadrant, really, we see all of the commands that are running. We see, again, the process IDs. We see the percentage of CPU and memory that each of them is using. We see what user they're running under, and then we see the command. And again, as I mentioned, the CPU utilization of Glances is right there up at the top. One interesting thing about Glances, in addition to all the other things it does, is down there at the bottom, you'll see that it says no warning or critical alert detected. It actually goes out and looks at you know, some of these numbers and says, oh, you know, gee, you know, your memory is 99% in use. And so it'll actually give you nice little warnings down there at the bottom. So if you want to throw this up on, for example, in a network operations center, if you were watching one machine, you could throw this up on the screen, and it actually watches and, you know, highlights things as they occur. So we know now how we can see processes. We know where to find them on the disk. Well, let's talk a little bit about what they're doing as far as network access. What are our servers listening to? Who are they sending traffic to and from? And we're going to look at this, and we're going to look at this through 3 commands specifically, and then I can go into a little bit more detail if we have time at the end. Netstat, ifconfig, and the IP command. So netstat gives us, and again, I'm old school. Old school, netstat was the way to go. I've now discovered that there are a couple of other commands that provide the same information, but provide it in what I guess the more recent Unix admins see as a more useful format. I'm just used to the old school, and it really works really well. So netstat provides me the ability to see the network connections that are currently active on the system. You know, is there a TCP connection to my named process? Is there, you know, is it open as a UDP listener? Netstat also allows me to see the routing tables, and again, as I said, the listening processes. Netstat may not be installed by default. It may be part of like netutils, I believe, is the package that I found it in. Netstat does use a lot of options. So in this case, I'm listening TCP, I'm not looking for the names, and I am doing this and showing the process names. And you'll notice here that I am ACLEG, and I had to execute a sudo command. In this case, to discover the process ID and program name, netstat actually needs to be run as the root user. So in this case, I had to become root using sudo netstat-lntp or LTNP, and it provides me with some very, very useful information. So here we see the protocols, they're TCP and TCP6, so we know that we're listening on both IPv4 and IPv6 interfaces. We see that the receive and send queues are empty. We see the local addresses. You'd say, well, the local machine only has one local address. Well, that's really not correct. It has a loopback interface, the 127.0.0.1. It also has an interface, or there's a nomenclature used in Linux where 0.0.0.0 is all interfaces on this machine. So in this case, I see that there is a named process, the very first line up there, the process ID of 1447. It is listening on port 5353 on the loopback interface. So 127.0.0.1, port 5353 is listened to by named. So I can go through and look at all of these and see that 5353, it's also listening on port 53 on the loopback. It's also listening on port 8053 on the loopback interface. And this machine's actual IP address is 44.127.8.1. And you'll see that I have another process, something that we'll be discussing in a later webinar called Do Client. And it's actually listening on port 53. I will leave that up to you to think about, and we'll discuss that in detail in a future webinar. So netstat, looking at the listening processes, I'm also able to look at the routing table. And in this case, I did a netstat -R, and it shows me the kernel IP routing table. In this case, the destination of default, so the default gateway, is through the interface or through the machine 192.168.42.129, and that is on the interface USB 0. The actual local network connection, 44.127.8, with a net mask of 255.255.255.0 is on ETH0, and then we see that the loopback interface is on LO. Now, why is this important? Well, if you have incorrect routing on your system, if you don't have, or if you have an interface that isn't connected, or a routing table that isn't pointing to the correct interface, then things aren't going to work. If you have your Kea listening on ETH0, but it should be listening on USB 0, or if you have your named listening on loopback, where it should actually be listening on ETH0, then you're going to run into problems. And this is something that you can use very easily to see where are my packets actually going. So in this case, any packet sent to network 44.127.8 is going to go out ETH0. Anything to any other network other than the loopback interface, other than 127/8, is going to go out the USB 0 interface. This also gives me a way to look at interfaces and to know where it is I'm supposed to be looking for specific traffic. So I notice here that I accidentally didn't highlight correctly the next command there, because it says aclag@boat.gw netstat-stat. Netstat gives you the ability to look at some of the statistics. And in this case, we're able to see the, and it goes on, this is only a very short bit of the total output, but we see the information about the IP stack. We also see information about ICMP. So we see, if you have something that's going strange, you're getting dropped packets for some reason, this would be a place that you would actually be able to see them and be able to figure out possibly why they aren't getting to the application or getting to the network that you would expect them to be getting to. Ifconfig, again, old school. I am an old school guy. I am doing things the way that I was taught back in the early and mid 80s. Ifconfig has worked since then, and it's beginning to not be installed by default. IP addresses, you can see all of your interfaces and their associated IP addresses, the V4 and V6 interfaces or addresses. You can see the MAC addresses of the hardware, and you can see the receive and transmit packet and error counts. So in this case, I do an ifconfig. I see ETH0. I see the flags that are associated with that Ethernet interface. We see the MTU. We see the IPv4 and IPv6 addresses. We see the hardware Ethernet address. We see the number of received and transmitted packets and any errors that have actually occurred during those, on those receive and transmit packets. The loopback interface, the same thing. We see the fact that it, now, something that's a little bit interesting and something that makes IP, which we'll see in a minute, a little bit better than ifconfig, is that the loopback interface only shows the INET address 127.0.0.2. Well, if you are a Unix admin, you recognize loopback. If you've done networking, you recognize loopback, and by default, it's 127.0.0.1. Well, in this case, I have created additional IP addresses on the loopback interface using 127 network, and the ifconfig command is only showing me one of those. We'll see something in a minute that will make it a little bit more useful. And again, down there at the bottom is the USB 0 interface. There's additional information that is below that but didn't fit on the screen and was just kind of repeating the above. So IP. IP is the new way to look at the network interfaces, the configuration of those interfaces, the routing tables, the ARP tables, and tunneling information. You can look at the IPv4 and v6 addresses, you can look at the MAC addresses, you can look at the routing tables, you can look at the ARP tables, and you can look at some very interesting, but not relevant at this point, tunneling configurations. So here I do the IP address. So IP takes a command, and the command in this case is address. And you'll notice that LO is the loopback, and we see that it is up. We see that it's MTU, we see some additional information. We also see that it has multiple IPv4 addresses. So we see INET 127.0.0.2, INET 127.0.0.3, and INET 127.0.0.1. This stuff was hidden from the ifconfig command, and this alone makes the IP command very significant and very easy to use. It's easy to parse, and it has all of the information, whereas the ifconfig command didn't provide us with the information. It does show us both v4 and v6 addresses, and in addition, we see the ETH0 interface, and we have the associated information for it as well. WLAN 0 was up, or it was configured, but there was no, it wasn't actually communicating, so we see the no carrier message. Netstat had the -r command where we could do a netstat -r and get routing table information. IP actually does it a little bit nicer, a little bit possibly easier to parse. We say IP space route. We get the route name or the route that is being sent to. It gives us the IP address to which it's being sent, the device on which it's being sent, and additional information about the interface. So in this case, we see our default route is through USB 0. The default traffic will be sent to the .129 address on USB 0. Network 44.127.8 is sent through ETH0. All of 127 is sent through the loopback. And again, all of 192.168.42, which is the routing interface, goes out through USB 0. We're also able to look at our ARP table. Now, ARP is the address resolution protocol. It's the layer under everything that we've looked at so far. It's the actual hardware addresses of the other devices on your network. So in this case, I can do IP NA for neighbor, and it's going to show us the IP addresses, and then the device through which we communicate with that IP address, and it gives us the linked local address of that device. So these are the actual hardware addresses of the devices on my network. So if you're ever trying to get to a machine and you're getting the network is unreachable or whatever, you can come in here and do an IP neighbor, and it'll show you if you were able to see that device and you're able to see the hardware associated with that device. And then there was something called systemd. And I'll tell you, as an old school Unix guy, which I may have mentioned that I'm an old school Unix guy, systemd kind of ruffles my feathers a little bit. It's a different mechanism that is used, that was initially going to be used for streamlining the init process. So you would be able to start processes during boot using a standardized format. You were able to prioritize things. No longer were things just done by running a script. You now had a controlling process that would run and make sure that everything started up as it should. Well, systemd seems to have grown a little bit and expanded in its plans, and so now it is used in a significant number of operating systems, and it does do starting and stopping and monitoring processes that start at boot. Lots of things change. So anytime a process starts, its initial log files are swallowed by systemd. You have to know where to go and look for them. The start and stop is no longer done by just killing a process and then running it again. You're going to use a systemd start, systemd stop, systemd restart commands. So in this case, I had on CentOS, I had downloaded and installed the binary package for named from the Red Hat sources. or from the Red Hat repositories, and I did an enable. So systemctl enable named.service. This says that anytime the system reboots, it's automatically going to start named. Then, so that sets it up to be enabled to start. Systemctl start named.service actually runs the command, so it actually does the things in the background that need to be, that start the actual application. And then to look at what's actually going on, what occurred during that startup, I can do a systemctl status named.service. Well, the beginning part up there where it says named service Berkeley Internet Name Domain, that's very nice. It shows us what that process actually is. It shows that it was loaded by this certain service definition file. We see that it is running. It shows us the date and time on which it was started and how long ago. It actually shows us the command that was used to start it. So we know that /user/sbin/named with those options are the ones that were given it to start. And then in addition, a few other things that were done prior to it starting. So we may have run this zone checking thing ahead of time. In the little C group down there, we see that it is run as named service. It is process ID 1456, and that is what we would find if we did a PS command. We would find that process ID 1456 is user sbin named with the given options. The network unreachable messages down there are the messages that occurred while named was starting before systemd actually thought, hey, it's up and running, so I can stop absorbing all of its error messages. So the messages here are being are stored within systemd or within a buffer somewhere that systemd maintains, but it allows you to see some of the messages that occurred during the actual start of the application. So with every systemd, you have to have this unit that you create. So this is the file that actually shows how named is started, or yes, how named is started. It has the description. It needs these other things. It has to start before this thing, but start after these things. And those are the things that systemd does very well, because I really don't want named to start before the network interfaces are available. So in this case, I know that because I'm starting after the network target, I know that the network has been started before bind is actually up and running. We see the service definitions there that show us some of the environment variables, some files that may be available, and then we see the exec start pre, which is the command that is executed prior to named starting, and then we see the exec start, which is the command that is actually run to start named. Then if you do a systemctl reload named, it's going to actually run that reload command. So we see that it's actually under the covers running RNDC reload, which is exactly what I would have done as a bind administrator. And to shut it down, it does a user sbin RNDC stop. I might have just killed the process. You'll notice that it tries first to do the RNDC stop. If that doesn't work, then it just kills the process. So we see that systemd, there are some unit files available for named and for Kea. So if you want to use systemd, you can. Now, one of the problems that I run into with systemd is that a lot of the packages are available that are available now know how to use it. So if I go out, I install something from the Red Hat repository, then I know that it's probably going to use systemd. But if I had this machine up and running and I had been installing bind from tarballs previously, then I might already have something installed that systemd is not going to know anything about, and it's going to start doing some ugly things, or the other way around. For example, I've been running the Red Hat version of bind for a long time, and I realized just how out of date and kind of Frankenstein it is. So I've decided I'm going to install my own self-compiled version of bind. Well, if we look at the output here, I've done a locate on /named, and then I've done a grep for named with a $$ $. $$ says, find the word named, but only when it occurs at the very end of the this input. So if named occurred in the middle, it's not going to be shown. In this case, etc named, etc log rotate named, etc rw tab, blah, blah, blah. We down here see /op/bind9/sbin/named, and I've highlighted these in yellow, user local sbin named, and user sbin named. Well, unfortunately, that's actually 3 different copies, or not copies, but 3 different versions of named. One of them may have been installed with a package. One of them, and the others were probably installed from, source code. We look at which named, and we see that one we're actually going to run if we type named and hit return is going to be the one in /sbin. Now that's all well and good if that's the same one that is actually started when we reboot the system. If we stop named and then we want to restart it manually, we have to be absolutely sure that we're running the same one that was running when the system started. Otherwise, things are going to get confusing very quickly. So if I run named-V, what this is going to do is it's going to look at the one that we saw just a second ago was the one that was run with when I said which. So this is the one out of /sbin. So /sbin/named-V shows us that this is bind 9.11.4 P2 Red Hat, blah, blah, blah. So this is the version that was installed with Red Hat's package. If I look at the one in user local sbin, using the user local sbin named-V, I see that it is bind 9.15.4 running on Linux, blah, blah, with all these options. This one is one that I actually compiled from source code. Well, that's all well and good. Again, if I have gone in and made sure that my startup scripts are running the one out of user local instead of the one out of /sbin, we have to be very careful about that, because what will happen, and I've seen this happen, and it will happen again, I absolutely guarantee, is that in the output down here where you see the ps-ef, and I did a grep for named, we see that there is a process 16502 that is running user sbin named with these options. And then there's also a process 16599 that is running user local sbin named with a different option. Well, that's going to cause some real trouble, because now what we're seeing is that we have 2 copies of named running, and that isn't going to be good for anybody because it's not listening correctly. And again, we'll get into this in a later webinar, but you don't want to see this. Make sure that when you start named in your startup routines on your box, that it only starts one of them, and that it starts the one that you're expecting it to start. So when you're looking for your configurations, read the configurations. Well, oh my gosh, how do I find the configuration for a given service? Well, for Kea, you can do a grep for Kea dash and then the name of the daemon.conf. And in this case, the name of the daemon can be Kea dash DHCP4, Kea DHCP6, Kea netconf. And in this case, I knew that the directory /etc/Kea contained these. So I was in that directory and did an ls, and you can see here are all of the configuration files. These configuration files are going to contain the locations of the logging. It's going to contain the locations of any additional input files. For example, in bind, it might have the input for the zone files, and all of the other information that you're going to need to do additional debugging on your system. For named or for bind, you want to look for the file called named.conf. In this case, I did a locate of named.conf, and again, I did a grep so that it only shows me the ones that have the word conf as the last word at the end of the line. And I needed to get rid of the stuff that was in my home directory. So we see the locate, the grep, and the grep-v. And in this case, we see that there is an etc named.conf. We see an etc namedb.conf. Pardon me. We see a user lib tempfiles.d named.conf, and then we see something in documentation. Well, here we have a problem because we need to make sure that named.conf, we only have one, we're only using one, and well, we might have more than one in the file system, but we want to make absolutely sure that when named starts, it uses the correct one. So again, when you start your processes, make sure they're looking in either etc or etc namedb. In this example, there could be many other places, /opt, and all the other places that, that things could be installed. So in this case, I'm in /etc. I do an ls-al on named star, and we see that in the directory itself, we have a configuration file, we have a DLV file, we have an RFC 1918 file, we have a root file, and we have a directory called named, which is empty, and we have a directory called namedb, which has in it bind.keys and a named.conf. This would be a very confusing configuration. This would not be a system that I would want to leave as is. I, as a Unix admin, would go in and clean it up and make sure that all of the files are, for any other versions are removed. Make sure that when my system starts, it uses the correct configuration. So if I look at the named.conf file, in this case, we see that it's provided by Red Hat package to configure ISC bind. We see down here a little bit farther, it has listen on port, it has listen on v6, it has directory /var/named. So now we know where we should start looking for our configuration files. In addition, we see the locations of the dump file, statistics file, and all of these other things. And we know where to start debugging our version of bind. So moving forward, I have 5 minutes left, and that's just about where I wanted to be at this point. What I've given you so far is a very short list of commands that you should be familiar with as a Unix admin. There are a countably infinite number of other commands to learn and use. So what I would recommend at this point is for you to go forth, learn Unix, experiment, set up a virtual machine. VirtualBox is free. The Linux distributions are free, most of them. Start it up, try it. You're not going to break anything too badly as long as you don't start a DHCP server on your real LAN. Go out and play, have fun, learn Unix. And we will go into more detail on a lot of these things in future webinars. We will go into some very specifics on how to debug BIND and Kea in future webinars, but I did want everybody to get familiar with some Unix command line stuff. And with that, I will open it up for any questions and comments.
So Ellen, while we wait to see if people type in questions, we have a bunch of comments so far, and I may just read through them. Whenever you get Unix folks together, you have different opinions and different preferences. So Rui in particular has, I encourage people to suggest their favorite commands in the chat, and Rui has gone ahead and suggested a bunch. He says command-v command is more modern, and there are some advantages, he doesn't say what they are, using it in lieu of which.
That's fine. And again, like has been mentioned, there's a countably infinite way of doing things on Unix. And honestly, it's my belief is one of the reasons that Unix didn't catch on as a mainstream home user operating system, because nobody wants to go in and learn 28 different ways to do things. I absolutely agree. There are things that I am not familiar with. I am more than happy to take additional input, and we'll revisit that as time permits.
So another suggestion he has is pkill might be easier to use than kill, I'm guessing, for less experienced users. I don't know what the difference is between
pkill allows you to give the process name instead of the process ID. So you can say pkill space named and hit return. The problem is that it is a little bit more shotgun approach, because if you have more than one named process, you might be killing off something that you don't necessarily want to. So yeah, it's available, and that is another option. I could list out 28 different. I can run the kill command from top, but that's just a different way of doing things.
Okay, let's see. So it's another comment for medium term stats. Installing the sysstat package and using the SAR command is also useful.
Yep.
There were
again, I had an hour to work with. and advanced statistics, which is pretty much what SAR is going to give you, is a little bit beyond the scope of this one today, but we might get into that in the future. Absolutely.
Right. Well, we can include some of these in the cheat sheet. So then there were a couple of comments about changes that are coming in more recent versions. IF config is not installed by default in the most recent Red Hat distros, and derivatives after 6.x.
Yep, that was mentioned on the slide.
Yeah, let's see. Another comment is netstat and IF config are going to be deprecated in Linux.
That's fine. So is NS lookup.
Yeah, and be replaced with SS and IP, which you discussed. IP. Hang on, there's something else in the chat. Here's a suggestion from Riyadh. Tail F.
Yep.
Var log messages shows the named activities in the system.
Absolutely. Tail dash uppercase F will actually leave the file open in the case of a daemon, reloading or restarting the log file. But yeah, tail dash F and tail dash uppercase F are very, very useful. Absolutely.
Okay, anybody have any other questions or comments? As you can see, the examples that Alan, that he had to pick and choose from a lot of different things to focus on, and I'm sure that his choices were really informed by what are the problems that he sees in support, the confusion around System D, that sort of thing. But if anybody wants to ask, what's the best way to look up something, this is a good chance to bring it up. Or if anybody has any other suggestions for other commands that in a cheat sheet we should highlight to new users, we'd love to hear them. Here's another comment from Jimmy Lang. Thanks for the webinar. Also, thanks for mentioning that while it's okay to play with Linux, be careful about starting DHCP servers.
Yep. You really don't want to take down your production environment. That would be a bad thing.
Yeah, that is a problem. Okay. I'm just chatting to see if there are any slow typers who have questions, but mostly we're just seeing comments and thanks. So I guess we can finish up. One thing we mentioned, Suzanne has put a link in the chat to a KB article that she basically scraped out of the webinar. And we'll look at some of these other suggestions. Perhaps we can add some of these suggestions that some of you folks who have attended the webinar have suggested we include. Otherwise, I think we're all finished. Thank you.
Yeah.
And
have a wonderful day, everybody, and I'll see you online.